So we feel that we should mention a safety discussion first because of the potential problems associated with creating a real piston robot. We're not opposed to the creation of a real piston robot. We just don't want the piston robot to be created in a manner where it could hurt somebody. We can open for you one of our piston robot drawings. And you can see here that we've opened up in PistonRobot a piston that we've designed. And this is just to give you a view of the pistons that we'll be using in the robot to move it. You can see that the piston can move its rod in and out of the cylinder, and it has connection points on either end of the piston so that the piston can be connected to the robot. And now we've drawn in some additional concepts with the robot. This is a very simple leg. You can imagine that this structure here could be seen as a pelvis or the beginning of the right side of the hip. So here is the pelvis, here's the right leg, this is the right hip. We've certainly put in here where this piston is connected to the hip in a manner where it can connect up to this leg. And the effect of this piston connected to this leg will be that this leg will have the ability to move. And you begin to see as this leg moves that if you will keep your eye focused on this area right in here, this is a potential pinch point. If this leg, if you had a hand or a finger inside any of these tight spaces and this piston functioned and moved this leg, you could easily crush or injure your hand. We've moved into a little bit more complicated section of the demo robot that we're creating. You can see here with this robot that these are some different positions that the leg can be in at the level of the hip, and those motions are controlled by this piston. That represents a clear pinch point where if there was a hand or a finger in here and this thing cycled or moved, it would clearly damage a person. This, as you can see in this view, is a very close tolerance between this piston and this supporting frame when the knee, and you can see that this, here's the pelvis, here is the thigh bone, here is a joint or motion area of the hip, here is the knee, the motion area of the knee. The foot will be down here, so if the knee is swinging this way under the influence of this piston, you can see that when the knee is brought up to its full flexion point, that this piston connection point becomes very, very close to this support plate. And that again represents a crush injury or perhaps a transection injury if a finger or a foot or a hand or an entire arm was somewhere inside of this. It would clearly be a way that you could injure a person. We've pulled in now. We're not in the demo section of the robot. We're in the actual potential piston robot. Again, you can see this is the hip area of the robot. The leg at this point is tilted out laterally towards the side. The foot of the robot is curled up, so if this was a human being standing, this human being would obviously not be standing on this foot. This human being would be standing on the other foot over here. And this leg, if this was the front of the robot, this would be the human's right leg. And if this is straight down, then the human's right leg would be pointed out away from the midline of the body. And in addition to being pointed out away from the midline of the body, the thigh would be straight up and down, but the knee would be completely flexed and the foot would be curled around. And we're going to show you all of this in much more detail later, but the point that we're trying to demonstrate in this section of this lecture is the magnitude of the multiple places throughout the robot where a pinch point injury can occur. And that's why we're having a safety lecture at this point. There's a possibility our computer may have a little blue alien living inside the computer. We asked him if he would help us to show you the name of the next video in our series about PistonRobot. And he said, sure.